All right, let's dive into something pretty amazing. We're going to uncover the invisible science that, well, literally holds our world together. And I mean everything, from the very chair you're sitting in right now, all the way up to the tallest skyscrapers on the planet.
You know that feeling when you're driving over a massive bridge, or maybe you're looking out the window of a jet at 30,000 feet, and for just a split second, this kind of terrifying thought pops into your head. What is actually stopping all of this from just breaking apart? It's a great question, right? And the answer, thankfully, isn't just luck or some kind of magic. No, it's a very specific and very rigorous field of science.
In that field, well, you could call it the science of strength. It's this whole discipline that's all about figuring out the rules that govern every single thing we build. And, more importantly, everything we trust with our lives every single day.
Okay, so the official name for it is mechanics of materials. And the core idea, it's actually pretty simple, but it's also really profound. It's the study of how solid stuff, any physical object responds when you put a load on it, when you push it or pull it. And we're not just talking about if it breaks. That's the simple part. We're talking about how it stretches and bends and deforms right up until that breaking point. It's about being able to predict materials' entire life story when it's under stress. A really great way to think about this is like structural medicine. Seriously, engineers are basically doctors for our buildings and airplanes. Their job is to diagnose the internal health of a structure, to see all those invisible stresses and strains, and make sure it's not just strong enough for today, but that it's fundamentally safe for all of us for the long haul.
So that brings up a pretty important question, right? How can these structural doctors be so darn certain? I mean, how do they know their designs and their predictions are actually going to hold up out there in the real world? Well, it all comes down to two really powerful, interconnected pillars. And that certainty comes from this awesome partnership. So on one hand, you've got theoretical analysis. This is all the math, the physics, using all those laws to predict how a material should behave. But, a prediction is just a good guess until you can prove it. And that's where the other pillar comes in, experimental validation. This is where engineers take materials into a lab and physically test them. They pull them, they crush them to see what actually happens. They're making sure that reality lines up perfectly with the math. So theory makes the prediction, and the lab confirms it's true. And get this isn't some new idea. This back and forth between theory and experiment has been the engine of progress for centuries. I mean, think about it. Way back in the 1500s, you had Leonardo da Vinci. We all know him as an artist, but he was also this obsessive experimenter, constantly testing the strength of different materials. Then, 100 years later, Galileo comes along and makes those experiments way more systematic. And then fast forward to the 1700s, and you get these brilliant minds like Leonhard Euler, who developed the beautiful mathematical theories that could finally explain the results everyone was seeing. It's always been experiment and theory, hand in hand, all through history. Okay, so that's the history. But how does all of that actually build into the toolkit of a modern engineer? Like, how do they take these huge historical ideas and use them to solve a very specific problem? Say, designing just one single beam for one specific building. Well, they basically have two kinds of solutions to get their answers. First up, you've got algebraic solutions. The best way to think of these is like master recipes. They're these general, all-purpose formulas that tell you the deep why behind a structure's strength. But then, for a real-world project, you need something more specific. That's where numerical solutions come in. This is where you take that recipe and you plug in the actual numbers for this bridge or this beam to get a single, practical number that answers the big question. Is it safe? You absolutely need both, the deep understanding you get from the recipe and the concrete answer you get from the final calculation. So, what's the big deal? Why does all this invisible science even matter? Simple. It matters because you're living inside of it. Right now. You rely on it every single second of every single day. All right, let's wrap this up. What are the key takeaways here? First, mechanics of materials is the science of predicting how stuff is going to behave when you put it under stress. Simple as that. Second, it is the absolute bedrock, the foundation for safely designing, well, pretty much everything around us, from buildings to airplanes. Its real power, its secret sauce, is that combination of theoretical formulas and real-world lab experiments. And it's that dual approach, that constant checking, that lets us build a world we can actually genuinely trust. So the next time you're crossing a bridge, or even just sitting in your office or flying on a plane, just take a second. Think about the incredible invisible science that's holding it all together. And that kind of leaves you with one last thing to think about. What invisible forces are holding your world together right now, in this very moment?